Hi, welcome. Today we're going to talk about quadratics. We're going to continue on quadratics. We're going to talk about zeros, roots, solutions. So in terms of those three vocabs which I just talked about, or phrases, so roots. So what are roots? Roots are the actual zeros again. So where my parabola crosses the x-axis. So again, zeros is again where my graph crosses the x-axis, and zeros are again where and if a parabola crosses the x-axis. So we have an example over here. We have two solutions. So we have two roots, we have two solutions, we have two zeros, -4 and 2. Over here we have one real root, one zero, and we have one solution. Over here we have no roots, we have no zeros, or no real roots, I'm sorry, no real roots, no zeros, and then no solutions. What we're going to do here is we're also going to add two equations. So for example, if I have another equation that I add in here, let's say it's going to be a linear. Okay, let's say it crosses there, and it's going to have a positive slope, up and over, up and over. So we can say here is that these two equations here, they don't cross, and so therefore there's no solution. Okay? And if they have no solution, it means that, again, they don't cross. So vice versa, you can look at it. Well, do they cross? No. No solution. Over here, if they cross in one location, let's say they're going to cross here. Let's say they touch there. If they touch there, then guess what? We have one solution because it touches at one location. If we have a line that goes all the way through, then there's 2 points of intersection. If there's 2 points of intersection, then guess what? We have two solutions. So be aware of that. We're going to be using this concept in this section as we move on. So the topic is going to be solving quadratic equations by graphing. So if you're going to go ahead and graph, I recommend, again, using Desmos. Desmos is free. It's user-friendly. You can have it on your Chromebook. You can have it on your phone. It's really easy to use. So when you're given an equation, it says solve here, right? Solve means we're trying to find the x-intercepts, if there are any. So you can go ahead and again, two methods. Again, you can go ahead and graph and see where it crosses. If it crosses, again, you have your solutions. Or you can factor. Right? And if you factor, again, what you end up doing when you factor, for example, right here, if you factor this over here, factoring, again, we can use the zero product property method to go ahead and solve for your x. If you go ahead and solve here, you're going to get x equals -3 and x equals 1. So those are going to be your solutions. So x -3, x equals 1. So again, those are your zeros, and those are going to be your solutions if you go ahead and factor. So again, two methods, graphing or factoring. So this is where we're going to have two methods of solving this. So you could solve here is we have an equation x squared plus 2 equals -3x. So the first method that I recommend doing is set it in standard form, and then you go ahead and you graph in standard form. So how do we get it in standard form? We have to move that -3 over here. So what we're going to do is we're going to say x squared plus 2 plus 3x equals 0. Again, when you have it in standard form, you put it in your calculator, Desmos. We're going to put it in standard form. Okay. Again, standard form, then you go ahead and graph. You go ahead and graph that. If it crosses, touches, or doesn't touch, then you have your answers, whether it does or not. Another way of doing this that I'm going to walk through in here a little bit is if you have, so that's going to be method number 1. Number 2 is going to be setting the equations equal to y. So we have two equations, x squared plus 2 equals y. Then we have negative 3x equals y. So now we have two separate equations, again, and the reason behind that over here is because we have, is really what you're doing is you're setting y equal to y. So y equals y. You're saying that that's equal. So if you set y equal to y, you have y equals x squared plus 2, and then y equals negative 3x. What you can do here is you can graph these two separate equations, and if they cross, that's your solution. If they touch, that's one solution. If they completely cross, then you have two locations, and so you have two solutions. If they don't cross, then you don't have a solution whatsoever. Okay, so let's go ahead and see first method, and then we'll do the second method. Okay, we're going to go and graph. We have, again, how do we find our vertex? You find x equals negative b over 2a, and that's going to be your x value in your vertex, and then we're going to try to find our y value of our vertex. And remember, in order to do that, you simply just plug in this value into your original function to find your y value. Okay, so that's how we got the vertex. Now, to find out if this crosses, let's find out where the vertex is at. It's going to be at negative, let's say 1, negative 2. So it's going to be negative 1.5, so right there. So we're going to have the vertex there at negative 1.5, and we're going to go down 0.25. So this is going to be 1. We're going to be right here, negative 0.25. So my vertex is going to be right here, right there, and it's positive. My a value is positive, so it's going to open up. So if it's going to open up, I know I'm going to have two solutions. Okay. What you can do here is we can factor to find out my x-intercepts. So that's what I'm going to do right now. I'm going to factor this. If I factor this, so again, this is factoring, and then if you need some review on factoring, make sure you watch the other videos. We have this, again, set it equal to 0. Set this equal to 0. We use the zero property method, and we solve for each x value. So x equals negative 1, x equals negative 2. So guess what? Right here, negative 2, negative 1, which means my graph is going to open up, and it's going to go up. And so there we go. We found the zeros. We found two solutions for this graph. So again, that's method 1, right? Method 1 is put it in standard form. Method 2 is going to be setting both sides of the equation equal to y. Okay, let's do that right now. So again, method 2 is we set the left portion equal to y and the right hand portion equal to y, and we graph those on the same graph. If they cross, then we have a solution, and we're going to find out. So you can see here that indeed they do cross. And where do they cross? Again, down here we graph the linear equation and the parabola, and guess where they cross? They cross at the x value of negative 1, and they cross at the value of x equals negative 2. So the idea is you can use both methods to solve. We factored, got my zeros, right? Method 1, or method 2 is graph the equation separately. You choose which one's simpler for you moving forward. Personally, me, I like using method 1. Okay, we're going to use, I guess, method 1 here. Put it in standard form, right? Standard form. We're going to graph. In order to graph, we've got to find our vertex. To find your x value of your vertex, you need to find negative b over 2a. Again, we find our x value. Right? We plug it into every single x value, and we solve for y. So y, in this case, equals 3. So my vertex is going to be at -1, -1, and 3. 1, 2, 3. Just from finding the vertex, let's see here, it's going to be -1 and then 3. Just by finding the vertex, we can tell if we have no solution, one solution, no solutions, or 2 solutions, right? We can find that out by looking at my a value. So my a value is positive, which means my parabola is going to open up. Okay, it's going to open up. If it opens up, it's not going to cross my x-axis. So if it's not going to cross my x-axis, guess what? I have no solutions. I have no real roots, right? I have no zeros. And we can try to factor, but you can't get any factors because what 2 things multiply to be positive 4, and when you add, gives you a positive 2. So it's unfactorable. So it's unfactorable. Another hint that it's not going to be, it's not going to result in a solution, 2 solutions, or whatnot. So again, sometimes you'll get stuff that's going to say, hey, guess what? No solution. That's fine. We're going to go over method 2 again. What you can take here is, again, method 2 is you need to take both parts of the equation, both the left and right, set them equal to y, and then graph them separately. If they cross, don't cross, then you'll find out if you have a solution or no solution. And so you can see here that we graphed them both separately, and there is no solution. So that was it. The main idea behind this video is graphing, either by factoring, finding the vertex, and we have 2 methods, so standard form and then graphing. Or method 2 is if you have both sides of an equation, set them equal to y, and then graph them separately and see if they cross or not. And I hope this video was helpful.